What is the secret to releasing high-quality software every single time? It's not magic, it's a methodology. It's called the Software Testing Lifecycle, or STLC. So, what exactly is it? Think of STLC as a structured sequence of testing activities, from analyzing requirements all the way to closing out the test cycle. Unlike just randomly testing things, STLC embeds quality checks at every single stage. In my experience, teams that follow STLC see a nearly 40% drop in post-release defects. Why? Because it forces clarity and alignment from the very beginning. So how is this different from the Software Development Lifecycle, or STLC? The STLC is actually a focused part of the bigger STLC. While the STLC covers everything from design to deployment, the STLC zooms in specifically on the validation phases: planning, executing, and closing tests. When you align these two cycles, something amazing happens. For instance, in a V-model project, I saw a 25% improvement in catching defects just by mapping each development stage to a corresponding testing stage. It ensures that for every piece of code written, there's a plan to test it. Let's break down the 6 phases of the STLC. It all starts with Phase 1, Requirement Analysis. This is where the QA team studies the project requirements to figure out what's testable. They talk to stakeholders and create a Requirement Traceability Matrix, or RTM, to map every feature to a test. This step is critical for preventing misunderstandings later on. Next is Phase 2, Test Planning. Here, a senior QA manager creates the master blueprint. This plan defines the scope, objectives, budget, and timelines. It's also where decisions are made about what tools to use, like Selenium or Junit, and whether to automate or test manually. A solid test plan addresses risks and dependencies before you even start testing. Phase 3 is Test Case Development. This is where the planning turns into action. The team writes detailed test cases, specifying inputs, expected outputs, and preconditions. They also create the test data needed. Think of it as writing the script for the tests to follow. A strong, well-reviewed set of test cases is your best defense against missed defects. Then comes Phase 4, Test Environment Setup. This happens in parallel with writing test cases to save time. It's all about configuring the hardware and software needed for testing. This is a technical step, often handled by system admins, to create a stable environment that mirrors the real world. A quick smoke test is run to make sure everything is ready to go. Phase 5 is the main event, Test Execution. Here, the testers finally run the test cases on the application. They log every result pass or fail. When a test fails, a bug report is created with all the details, including logs and screenshots, and sent to the developers. After a fix, the test is run again. This phase is all about validating that the software actually works as intended. Finally, we have Phase 6, Test Cycle Closure. This isn't just about stopping, it's about learning. The team prepares a final summary report, evaluates the entire process, and captures key metrics like defect density. These lessons learned are invaluable for making the next test cycle even better. Now, a key concept that governs this whole process is entry and exit criteria. These are like quality gates for each phase. Entry criteria are the things you must have before you start a phase, and exit criteria are what you must complete before you finish. For example, you don't start writing test cases until the test plan is approved. This discipline prevents chaos and ensures nothing gets overlooked. Let's talk about automation. In STLC, automation means using tools to run tests without manual effort. It's perfect for repetitive tasks like regression tests. Teams usually decide what to automate during the planning phase, and the return on investment is huge. I've seen automated tests cut down total testing effort by up to 20% and catch bugs much earlier, which makes them cheaper to fix. Of course, STLC looks a bit different in agile environments. Instead of a long, sequential process, testing happens in short, iterative cycles within each sprint. Developers and testers work together continuously, which leads to faster feedback and quicker releases. In a CI/CD pipeline, testing becomes fully automated, triggered every time new code is committed. To keep track of everything, a centralized dashboard is a lifesaver. It pulls all your key metrics like test coverage and defect rates into one place, giving everyone a real-time view of software quality. This data-driven approach helps teams make informed decisions and has been shown to reduce post-release defects by up to 40%. So, to wrap it all up, the software testing lifecycle is the backbone of modern quality assurance. By following its structured phases, from requirement analysis to test closure, teams can ensure thorough coverage, catch defects early, and deliver high-quality software that users will love. With the demand for skilled testers on the rise, mastering STLC is more important than ever. Thanks for watching. If you found this helpful, please like, subscribe, and hit that notification bell for more insights into the world of software development. See you in the next video.